How are you, friends? Hope you are doing all well. So, in this episode, we will uh, obtain velocity and acceleration of the wave. Okay, so velocity, we know that a particle speed varies with respect to time. It may remain fixed or it has variable magnitudes. So with respect to time, displacement varies. Therefore, if we differentiate displacement with respect to time, then we will get velocity expression. So velocity is equal to rate of change of displacement. So it is displacement divided by time. Rate of change of displacement with respect to time. So here we can differentiate displacement with respect to time. So velocity v is equal to differentiation of displacement equation. Okay, velocity is the differentiation of displacement equation with respect to time. So here we will put the value v equal to differentiation of what? A cos omega t, a sin omega t, like that. Okay, so a cos omega t plus phi. Okay, so here a is a constant value. If we differentiate amplitude with respect to time, we will get 0. Okay, so then cos function varies with time t. Cos function is varying with time t, so we will differentiate cosine of omega t plus phi only. So is equal to a differentiation of cos omega t plus phi. Okay, so when we differentiate cos, we will get negative value of sine. So sine a, and differentiation of omega t plus phi becomes what? Omega. Only omega we will get, and differentiation of time upon time. And differentiation of phi with respect to time is 0, because phi is a initial value and initial value remains constant with respect to time. So here we have omega, differentiation of time with respect to time gives us 1, and this value is 0. So this one, differentiation of omega t plus phi becomes omega, so it gives us value omega. Okay, from this angle. And differentiation of cos is sine, so sine omega t plus phi. The expression for velocity is v equal minus a omega sine omega t plus phi. This is the final expression for the velocity expression. When value of omega t plus phi varies, value of velocity varies. Okay, so maximum value of velocity can be v is equal to minus a omega. Okay, a omega, because maximum value of omega t plus phi is plus 1, so it gives us a omega. And when sine got minimum value minus 1, we will get plus a omega value. Similarly, we can obtain acceleration equation. So again, differentiating expression of velocity with respect to time, we get what? Acceleration is also time varying, so it is differentiating velocity expression. Because velocity expression is time dependent, we have seen earlier, so we can write like this: differentiation of velocity. So now we will write expression for velocity So it is differentiation of a omega sine omega t plus 5. So omega and a are constant value. When we differentiate omega and a, we will get 0 value. Okay, so that term will be 0. Now sine function is a time varying function. We can differentiate sine omega t plus 5. So omega a is differentiation of sine omega t plus 5. It becomes acceleration. So now when we differentiate omega t plus 5, we will get omega. Previously we have done it. So differentiation of omega t plus 5 is omega, and differentiation of sine of any angle with respect varying with respect to time is cos. So cos omega t plus 5. Okay, so it gives us omega square a cos omega t plus 5. So this is the expression for acceleration of the simple harmonic motion. Okay. As displacement varies from minus a through 0 to plus a maximum displacement, similarly velocity also varies from omega minus omega a to omega a, and acceleration also varies from omega square a to omega a, the negative value. Okay, minus omega square a to omega square a. Here there is one negative sign, so we will put this negative sign here. So if force acting on the object or a particle, force acting on the particle varies with time t, then a particle with mass m accelerates, isn't it? So if force is time varying, then oscillating particle accelerates. So now we can write a is equal to minus omega square a cos omega t plus 5. So it becomes f t is equal to function of time t is equal to minus m omega square, and this is the displacement part. This is the displacement part, so we can write omega square x function of t. Okay, so x function of t. Then ft is equal to mass and omega square is a constant. Mass and omega square is a constant, so we can write any value k xt. Okay, displacement varying with time t. So here from this equation k becomes minus, sorry, this plus minus is here, so m omega square. So omega can be written as under root of k by m. Then here Omega is the expression of what? Square root of k by m. K is what? Here it becomes force constant and m is the mass of the particle. So one thing we have seen here is force is equal to minus kxt, means what? Displacement. So this shows that force acting on the particle and displacement are opposite to each other. Direction of force and displacement is opposite to each other because force is this force shows the restoring force which tends to bring the oscillation back to its mean position, motion of the particle back to its mean position.